Hello Math Minds, this is Mr. Miller and welcome to lesson 2.1 on comparing and ordering rational numbers. So before we get into the definition of a rational number, I'd like to talk about a few different sets of numbers. So this is some rough work that you're going to see showing up in this space, and you don't need to write this down. Alright, so first of all, there are lots of sets of numbers. We can start with the most basic set, the counting numbers or the natural numbers. And these are the numbers that go like this: 1, 2, 3, 4, 5, and so on. Okay? If you want to add on 0 into that list, now we're talking about the whole number. So some people will label that as an n sub 0, while other people will label that with a capital W. But with sets of numbers, we always use capital letters and we use a boldface. So throw in an extra line there just to indicate that it's boldface. So again, the set is starting with 0 and now having 1, 2, 3, and so on. So that's the set of whole numbers. If we throw in the negatives, now we're talking about the integers. So integers, the sort of old school symbol for it is capital Z, boldface. And some people prefer to use capital boldface I. And so this is the same 0, 1, 2, 3 from the whole numbers, but in addition to that you also have negatives, so -1, -2, and -3, and goes on like that. Alright, so now let's take a look at some other types of numbers. These aren't all the numbers that we use in high school math. We also use numbers that have decimals. They could be fractions. You can have things like, let's say, 1/4. Well, 1/4 as a decimal is 0.25. That's a terminating decimal. So when you start looking at decimals and fractions, we want to start doing some classifying here. And so one of the ways to do some classifying is look at it in decimal form and see what you get. So terminating decimal is one type. Another type would be, whether you want to write the fraction as a mixed fraction like this, 1 1/3, or whether you want to write that as 4/3, because, and hopefully you understand what I'm talking about here. When you have a whole that you're dividing up into 3 parts, then if you have 1, 2, 3, 3/3, that's one whole, and then one more third, that gives you 4/3, that's 1 1/3. Take a look at, well, what is the value of 4/3? So if you're not sure how to change fractions into decimals, you can just take the numerator and divide by the denominator. If you've got it in mixed fractional form, you can always take the whole number part and add the fractional part to it. So you can see that another type of decimal that we can get is one that repeats. So if it terminates or it repeats, and there's lots of other ones like this. I mean, they can be positive, they can be negative. You can have fractions sometimes like 2/1 that actually, or let's say -2/1, this number -2 doesn't even have a decimal part to it. You can still include this in the same set of numbers. So basically any number that you can write as a fraction like this is a rational number. Now we don't actually use R for rational number, we use Q. So capital Q is a set of rational numbers, and you might wonder, why Q? Because Q stands for quotient, so it's numerator divided by denominator. If you can't write a number as a fraction, then it is the complement of the set we just discussed. And so basically we've seen, although I didn't do a huge number of examples here, you can see that with fractions, with numbers that can be written as a quotient or a ratio, that we always end up with either a decimal that terminates, maybe no decimal at all, or the decimal repeats. So what if we have a number that has a decimal that goes on forever, but never repeats. So you know what I'm talking about. Pi is one of those. And there are lots of other numbers like pi that the decimal goes on forever, but it doesn't repeat. To find some other ones, I want to talk about squaring and square rooting. So if you square 1, it means you're doing 1 times 1, and that's just 1. Squaring 2 gives you 4. Squaring 3 gives you 9. And if you don't know your times tables, I mean, you are allowed to use your calculator. 3 squared. Let's just do this. 3 squared, right? And so on. 4 squared is 16, and so on and so on. It's good to know those perfect squares. Now, going the other way around, if you are taking the square root, so if you're taking the square root of something like 16, then that gives you back 4. So the square root is looking for the number that when you multiply it by itself, you get the number underneath the radical sign here. So likewise, if I took the square root of 25, then this would give me 5. But if you try to take the square root of anything in between, so let's say the square root of 20, what you'll find is that in taking the square root of 20, you will get a number like this, 4.472135955. And this goes on forever and doesn't repeat. So basically the square roots of anything that's not a perfect square, so 1 is a perfect square, 4 is a perfect square, but the square root of 2, the square root of 3, and so on, even the negative versions of these, so the negative square root of 5, these are decimal numbers that go on forever, they never repeat, they are irrational numbers. It is not possible to write these numbers as fractions. So that's just a little bit of an introduction into the sets of numbers, and now we can get back to our lesson and just focus in on the rational numbers. So let's get a definition going here. Definition of a rational number is a number that can be written in the form A over B, where A and B are integers and B is not equal to 0. So back to the rough work page, why did I say B is not equal to 0? There's a good reason for that. So whenever you do division, so let's say you have something like 8 divided by 4. Probably when you first learned about division, and of course you know the answer is 2 here, you're probably able to figure this out because relate it back to something that you probably studied before you studied division, which was multiplication. So you know the answer is 2 because 2 is the number that when you multiply it by 4 you get 8. So that's all great and everything, but what if we start throwing in zeros in there? So what is 0 divided by 4? Well, that's equal to, if you weren't too sure, you could relate it back to multiplication. Say, okay, so I'm looking for that number that when I multiply by 4 I get 0. Oh, well that's 0, so you can get an answer to that, no problem. But what about if you are dividing by 0? So what if you have 8 divided by 0? Then what? Say, okay, well I'm not too sure, but I know that I can relate this back to multiplication, and I know that it should be the number that when I multiply by 0 I get 8. So I usually ask this in class and get some people, enthusiastic people saying, Oh, I know it's 8. No, 8 times 0 is 0. Oh, I know it's 0. No, 0 times 0 is 0. 1. No, 1 times 0 is 0. So you start to wonder, what the heck is this supposed to be then? And the answer is that it's kind of like, it's nothing really. It's not nothing, not 0 nothing, but this is an this is an expression that is undefined. Okay? So basically, you can't divide by 0, not even if you're Chuck Norris. So going back over here, we say in our definition of a rational number that a rational number is a number that can be written in the form a over b, where a and b are integers and b is not 0. So in identifying the rational numbers here, number 1a, you can identify that 17 over 1 is a rational number. Okay, 17 is 17 over 1, so that's a rational number. 5 over 0 is not a rational number, so you're not allowed to have a 0 in the denominator. You take a look at this and you say negative 3.606. Well, for one thing, I know it terminates, so I know that this is a rational number. The other thing is, I know that I can write it as a ratio, as a fraction, negative 3606 over 1000. Right? You can't do that with the square root of 3. If you start taking a look at the square root of 3, numerically, you will see that the square root of 3 as a decimal goes 1.7320, blah, blah, blah. Goes on forever, never repeats. So what about negative 8 3/4? So negative 8 3/4, or if you like, you can say that this is, well, there are 8 whole parts to this, so in each whole there are 4 quarters, so 8 times 4 is 32, plus another 3 is 35 quarters. But don't forget, this is negative 35 quarters. That makes it easy to do this calculation. Negative 35 divided by 4, and that's negative 8.75. So this is a decimal that terminates. On top of it, we can see that we can write this in the form a over b, where a and b are integers and b is not 0. So absolutely, this is a rational number. Start looking at some more examples here. This is a number that terminates. Definitely can be written as a fraction, so negative 2/10. And yeah, I realize that can be simplified, but it's not really our main concern here. This is one that repeats, so that's okay. And it's 9 and 12/99. So I don't expect that people would be able to convert 0.1212121212 into a fraction. But I would expect, so just double checking, 12 divided by 99, yeah, that is 0.12121212. I do expect that my students would know that 1/9 is 0.1 repeated, that 2/9 is 0.2 repeated, that 3/9 or 1/3 is 0.3 repeated, and so on. 4/9, 5/9, 6/9, which is also 2/3 in those terms, 7/9, 8/9, and 9/9 is 0.9 repeated. Now this is a little bit of a funny one. It's 1. So yes, you heard me right. I said that when you have 0.9 repeated, it's equal to 1. Back to the examples here. 0 divided by 0. Dividing by 0 is not allowed, so this is not a rational number. This one here, negative 13 over 4, obviously this can be written as a fraction. And to get the numerical value to it, negative 13 divided by 4, you can see it's negative 3.25. And 7.1234, well, the dot 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 indicates that it goes on forever. There's no indication of repeating here, so this would not be classified as a rational number. Okay, opposites. Opposites are pretty easy, really. So the opposite of a positive is a negative. So here are the positives, and the opposites of these positive numbers are negative numbers. Okay. The opposites of negative numbers are positive numbers. So positive 23 over 3 is the opposite. Positive 17.6 is the opposite here, and positive 7 and 5/7 is the opposite there. Okay. Next, we want to do a little bit of matching of letters on the number line with one of each of these rational numbers. So the first one is 7/4, which you could write as 1 3/4 if you like, because you recognize that 4 goes into 7 once with 3 left over. Or you could write it as 1.75, so whatever you prefer. But I can see that in between 1 and 2 there's only one letter, that's D, so that is the answer. If you look at this closely and you divide this up in half and then into quarters here, that's at the 3/4 mark between 1 and 2, that's where you see D. The negative 0.3, or negative 3/10 if you like, looks like it's either A or it's C. It's a little bit tricky to tell which one is which. Probably not E, but let's see. So we'll come back to this one. Let's go on to 2 1/5. So 2 1/5 is 2.2, and basically we can see here that's F. There's only one letter that's in between 2 and 3, so that's kind of obvious. If this were divided up into 5 parts, this would be 1, 2, 3, 4, 5. Or if you're looking at it as 2.2, if you divide it up into 10 equal parts, then there's your 0.1, 0.2, 0.3, 4, 5, 6, 7, 8, 9, and now we're up to 3. Okay, next we've got negative 1/3. And negative 1/3 is negative 0.3 repeated. So now we got to do a little comparison between the negative 1/3 and the negative 0.3 and just figure out which one should go where. So before I get to that, maybe we'll take a look at something a little bit easier to compare. If we compare, let me just take some of these things off so I can have some room to do some work. Okay, so we want to take a look at negative 0.3 and negative 0.3 repeated, but maybe it'd be easier initially to look at positive 0.3 and positive 0.3 repeated. So the 0.3 is 0.3, and then it's got zeros afterwards, dot dot dot. And this one is 0.3333333. So you can see that the 0.3 repeated has got more to it than just 0.3. And so you can see that 0.3 repeated is bigger than 0.3. So on the number line, when we're talking about here's 0 and here's 1, and if you look at where is 0.3 and where is 0.3 repeated, they're pretty close together. So, but 0.3, since it's a little bit smaller, it's a little bit closer to 0, and then the 0.3 repeated is a little bit further away from 0. You start talking about negative numbers, it works the opposite way. So here's negative 1, and so negative 0.3 would come first, and then negative 0.3 repeated. So negative 0.3 repeated is smaller. It's further to the left on the number line. And so now this allows us to answer this question. Since the 0.3 repeated should be further to the left on the number line, should be further away from 0, that should be A. And that means this one should be C. Negative 2.1, or negative 2 1/10 if you like. You can see that between negative 2 and negative 3 there's only one letter, and that's B. And finally we have negative 0.49 repeated. This is really equivalent to negative 0.5, and you can see that between 0 and 1 the halfway point is E. And just be careful because that could be kind of sharp, you know, because it's pointy. Get it? Anyways, all right, so enough with the number line there. Let's take a look at putting numbers in ascending order. This means that they're getting bigger. And I say getting bigger, going left to right. So that's ascending. If it was descending, then it would be getting smaller, going from left to right. So we want to do a comparison of these numbers. And it's doable, but we're comparing fractions and decimals. And so it may be easier to convert them all into one form and work with them. The easier way to do this is to change them all into decimal form. So we've got negative 3/4 is negative 0.75. If you weren't sure that's what it was, you can always do that on your calculator. Just go negative 3 divided by 4, and there you go. The next one is 1.7, so that's already as a decimal. The next one is negative 0.6, already a decimal. Next one, 1.5, that's 1.5 as a decimal. Again, with mixed numbers, you can take the whole number, 1, and add the fractional part, 1 divided by 2. And the last thing we've got here is negative 0.6 repeated. So initially write everything as a decimal, then put them all in order. So we've got negative 0.75 is the furthest away from 0 on the negative side. It's further to the left. Then we have negative 0.6 repeated, and then negative 0.6, and then 1.5 and 1.7. Whoops. Okay, so now that we've got these in order, we should put them back into their original form. So if it helps, you can always do a little bit of color coding if you like. So if I like here, I'm just going to take this and I'm going to take a look at where did the negative 3/4 go. Well, that was here. It stayed in that leftmost position, so I'm okay that way. So I know that this first number that I should write here should be negative 3/4. And the second number, okay, so let's take a look at what's next. Alright, so we had 1.7 still here. The 1.7 got moved way off to the side here, the right end, and so in original form it was 1.7. It was already in decimal form, so I'm going to leave it that way. Let's track where the next number went. So pick a different color here. How about orange? And negative 0.6. Ooh, that's a little too close to the other color. Maybe I'll just choose this one. Still not much different. How about pink? Oh yeah. Negative 0.6. So it was already in decimal form. It moved over one spot to the right, and so this middle position one was negative 0.6. So it already was a decimal. We'll leave it in its original form as a decimal. Okay, so let's take a look at the next one here. We've got, and how about purple, 1.5. Oh yeah, that's nice. That's 1.5. Where did the 1.5 go? Right here. So this one is the 1.5. So I'm going to write that back in its original form, 1.5. And finally, just need one more color. How about yeller? Old yeller. So there it is, moved over to this position, and so I'm going to write it right here as it was originally, and it was in decimal form originally, so negative 0.6 repeated. So, isn't that colorful? So just going back to how we went through this process here. You don't necessarily need to do all the coloring that I did. I just thought it would make it easier to track where all the numbers went. So in my first step here, I really just converted all the numbers into decimal form. Second step here, I put them in order. And then third step, any number that I had changed its form, I'd go back to its original form. Now, is this the only way to do it? No, but I think you're probably going to want to go with that method, because if you take a look at the other way of doing it, it's quite complicated. I'll give a really quick explanation of how you can do that another way. So this is sort of method number 1. And this is your final answer here. But there is another method that you can use. So I'm going to show you another method, and that's to work with the fractions. I don't think this is going to be everybody's favorite though. So negative 3/4 is already a fraction. The 1.7 you can write as 17 over 10. The negative 0.6 you can write as negative 6 over 10. The 1.5 you can write as 3 over 2, just to have it all the same as numerator over denominator, no mixed parts to it. And the last one, negative 0.6 repeated, well, that's negative 6/9, which reduces to negative 2/3. So even the 6/10, you could look at that and say, well, that really reduces to negative 3/5. Oops, I guess I don't need another negative sign in there. So we've got them all as fractions, and that's a first step that you can take. Second step that you're going to need to take is to change them all so that you have a common denominator. So you got to look at multiples of 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, multiples of 3, 3, 6, 9, 12. Basically, with 2 and 3 as denominators, you got to be looking at multiples of 6. Multiples of 5, multiples of 10s, multiples of 4. Least common multiple between all of these is going to be 60. So we got to change all of these into 60ths, and then we can put them in order. So this is a good exercise to do, but of course it's very time consuming, and I don't expect people are going to want to do it this way. So what would you do? You'd multiply the top and the bottom here by 15. That would give you negative 45/60ths. Multiply the top and the bottom here by 6. That gives you, oh boy, 17 times 6. 102. Multiply the top and the bottom here by 12. That's negative 36/60ths. Multiply the top and the bottom by 30. That gives you 90/60ths. Multiply the top and the bottom here by 20. That gives you negative 40/60ths. So now you're going to be able to move on and put them in order. So you know that the negative 45/60ths is the least of this group, and then you've got a negative 40/60ths, followed by a negative 36/60ths, followed by 90/60ths, and then 102/60ths. So now, and so basically what we're saying is that's our step 3 here. Step 4 is to write them back in their original form. So that means going back to the negative 45/60ths, that was negative 3/4. I'm not going to bother with the color coordinating. This is a little bit time consuming, and hopefully you can track where all the numbers went. The negative 40/60ths, well, that was negative 2/3. That was negative 0.6 repeated. So negative 0.6 repeated is the next one. Then we've got negative 36/60ths, which was oh yeah, negative 3/5. Well, that was negative 0.6. So negative 0.6 here. And then 90/60, that was 3/2. That was 1.5, writing it back in its original form. And finally, we have 102/60ths. And the 102/60ths is 17/10. That was the 1.7. So 1.7 is the last one. And I mean, you certainly could do it both ways and then compare that you got the same answers for both. You can see I do have agreement here between this and that. Okay, so that one was a little bit time consuming. Of course, you don't have to write down both methods. You choose which method you prefer, and I think probably most people would go with this method here. Okay, heck of a lot easier to work with the decimals, okay, instead of working all in here with fractions. So probably not as desirable to do that, more time consuming, more steps to take. It's pretty tricky stuff. Alright, so let's take a look at the other examples that we have here to do. So we'd like to identify the equivalent fraction pairs next. And so an easy way to be able to compare them is to have them written in lowest terms. So negative 5/2 is this written in lowest terms, dividing the top and the bottom by 2. This one is positive 5/2, so these are not equal to each other. So that's not one of the pairs we're looking for. Negative 7/14 does reduce to negative 1/2, so obviously negative 1/2 is equal to negative 1/2, so this is one of the ones. Negative 5/2, a negative divided by a negative is a positive, so we have 5/2 and 5/2. These are equal, so they are equivalent fractional pairs. Now we want to take a look at some equivalent rational number pairs. So we have negative 3/2. So a negative divided by a negative is a positive, and changing this improper fraction into a mixed fraction, you can see it's the same thing as what we've got on the right. So that's an equivalent pair. You could always convert these into decimal form if that's something that's easier for you to do. You can do negative 3 divided by negative 2, and then compare that with 1 plus 1 divided by 2, and you'll see they're equal. So how about this one? We've got 4.6 repeated, and so let's work with the decimal form. 4.6 repeated. If you do 4 2/3, it's going to be 4 plus 2 divided by 3, and you'll find it's exactly the same thing. So this is another equivalent rational pair. How about this one? We've got negative 0.8, and we've got Negative 4 divided by negative 5 is going to be a positive. It's 0.8, but it doesn't have the same sign, so these are not equal. So that's not an equivalent rational pair there. Okay, so now we want to take a look at these pairs and find out which one is smaller. So on a number line, you know that 0 is in the middle and we've got positives on this side and negatives on that side, so that means a negative number is always going to be smaller than the positive number. Don't really need to do much more than that. Now, to compare these two, one way would be to look at them with a common denominator. So you'd have to multiply the top and the bottom of the first one by 9, multiply the top and the bottom of the other one by 8. So just comparing them, you can see 64 70-seconds, that's bigger than 63 70-seconds. So that means this is the smaller one. Okay, the question was identify the smaller value. And so I'm circling the one that's smaller. Alright, so negative 3/7 and negative 4/7, of course they already have a common denominator to them. So you might think, oh, 4 is bigger than 3. Yeah, but don't forget these are negative numbers, so they work the other way around. The negative 4 moves it further away from 0 than negative 3. It's more to the left, so this is the smaller number. Okay, and again, if you'd like to see that on a number line, you could always just take a look at it. Here's 0, here's negative 1. If we break this out into 7 parts, 1, 2, 3, 4, 5, 6, 7. So here's negative 1/7, here's negative 2/7, here's negative 3/7, here's negative 4/7. And so negative 4/7 further to the left than negative 3/7, so it is the smaller value. Alright, next, for each of the following pairs of rational numbers, we want to write the rational numbers in decimal form. So in decimal form, I have 0.25 and 0.5. This is a pretty easy one to do. But if you ever aren't sure what a fraction is as a decimal, just take numerator, divide by denominator. Again, 1 divided by 2, and that'll give you your answer. So now we want to figure out what decimal would be between each pair of decimal numbers. So in between 0.25 and 0.50, anything you like, 0.3, 0.4. Basically, you can see that 30 is between 25 and 50, right? But just remember that when it's a 0 afterwards, it's optional to write that. So now how about with negative 1/10 and negative 1/8? So as a decimal, this is negative 0.1. The other one is negative 0.125. So again, it might be handy just to look at this as being like negative 100 and negative 125. So in between them, maybe something like negative 112. 0.112, so that would be a decimal number that's in between these two. So anything would do, negative 0.101 even. And part C, just like Moses, negative 0.6 repeated when you change that to thirds into a decimal. And also looking at negative 5/6, you'll see that's negative 0.83 repeated. So comparing 66 and 83, anything in between would do. Even just 70, 0.70. 0 is optional to write. And don't forget we're dealing with negatives here, so you put that out in front. Okay, one last page to do. For each of the following pairs of rational numbers, we want to write the rational numbers in fraction form. So when you have a single decimal place, you can just put it over 10. And you can put the 9 over 10. You can reduce the lowest terms by dividing the top and the bottom of the first one by 2. Not totally necessary, but trying to find a fraction in between these pairs of fractions. So between 8/10 and 9/10, you might say, oh, there's nothing. Well, you could write it as 8.5/10. Of course, that's not really a fraction because the numerator, neither the numerator nor the denominator should have a decimal in it. So if you double the top, double the bottom, double your pleasure, double McGum, you get 17 over 10. And that would be, 17 over 20. And that would be in between the two. So 17, just as a double check here, 17 divided by 20 gives you 0.85. Yes, that is in between the two of them. And that's another way to go with this. Instead of working with the fraction, so I can write this as negative 65/100ths and negative 66/100ths. And I could reduce that to lowest terms, but I'm not going to bother right now because there's nothing in the instructions that said I absolutely need to. Usually we do like to have answers in simplest terms, which means reduce, but I'm not going to bother here. I'm really interested in what fraction would be in between the pairs. So why don't we look at it this way? This is negative 0.650, this is negative 0.660, so what about negative 0.655? That would be in between these. So I could write this as negative 655 over 1,000. And that works. So come up with the decimal first and then change it into a fraction. But of course, if you're looking to find this in lowest terms, your calculator will do it for you. You could do negative 0.655, and then depending on your calculator, you may have an ABC button. For me, I go math, enter, enter, and it'll convert it to a fraction in lowest terms, negative 131 over 200. And basically what it did was it just divided the top and the bottom by 5. Okay, last one in number 9 here, we've got negative 9/10 and negative 10/10. Sometimes that trips people up because the negative 1, they're thinking negative 0.1. No, it's negative 1.0. So in between the two, you could say it's negative 9.5/10, or double the top and double the bottom, you get negative 19/20. So that works. Next, we want to look at each rational number as a fraction or mixed number in the lowest terms. So this is 7 over negative 14, and reducing it to lowest terms, you got to divide the top and the bottom by the same number. Greatest common factor between them is 7. It gives you negative 1/2. Next one, negative 75/100ths, you can divide the top and the bottom by 25, and that will give you negative 3/4. Negative 4.4, you can write this as negative 4 4/10. When you reduce this, you divide the top and the bottom by 2. You don't change the whole number out in front. So that'll work. Of course, you could look at it as negative 44/10 and reduce that down to dividing the top and the bottom by 2. You get negative 22 over 5. So either of these would be acceptable. I don't have a preference between mixed numbers and improper fractions. Okay, integers in between negative 9 over 2. So negative 9 divided by 2 is negative 4.5. Negative 9 divided by 2 is negative 4.5. And then 16 divided by 3 is 5.3 repeated. So, on the number line we've got these two numbers, and then we're asking what are the integers that we have in between. Well, there's -4, there's -3, there's -2, there's -1, there's 0, and then there's 1, 2, 3, 4, and 5. So these are the integers that are in between those two rational numbers. And that is it. So thank you for watching this video and have a lovely day.